Okay, so my idea for today is trying to add even more syscalls to the cool programming language and to the standard library that we have. And yeah, like the last time we managed to get let's see the examples. So the game, right? We managed to make a snake game, even though this didn't require the syscalls, but you know. And basically this time I want to add more syscalls, and especially the ones for the networking part, like socket, connect, accept. And yeah, we'll see how many we can do. Maybe try to get like these, socket, connect, yeah, some of these, so that we can make a web server or something in this language. That would be interesting. So yeah, sure, let's see. So we have to edit the Linux file, right? The Linux file. And basically, where's the exit? All right, so connect, or I guess the first thing that's usually called is socket, right? Or let's see, socket, see example. Let's see how like the basic thing is implemented in C. So usually you would have something like socket here. You create a listen file descriptor. So basically that's the first thing that we actually have to implement. Let me just zoom this in a bit. But yeah, so we need to implement the socket syscall. So let's take this one. It's gonna come here. Socket. So we can also take a look at the socket man page. Not really. Maybe like this. I guess like this. So it gives the domain, type, and protocol. So let's see, domain, type, and protocol. I mean, ChatGPT almost got it, right? And maybe, I'm not even sure. Like these are all the stuff that we can use, right? Would be nice to have some sort of constant variables. And here, for example, they use AF init, right? So let's say we want to see what value this thing has. Don't really know. How would we get that? It's a good question. Even sock stream. That's also a good question. And the last one, I guess, 0 is, I forgot for what, for the protocol, which I guess refers to be honest, I don't know. I thought it's like a TCP or something. But yeah, so we would get a file descriptor there. That's pretty nice. Alright, so let's see how we can get the values for these things. I would say that's kind of needed. There's also this thing. So yeah, like bind, I see that it's although bind, let's take a look. Man to bind. Yeah, it takes like in a structure here. but I guess yeah, it's 3 arguments. It takes in the socket file descriptor, the structure, and the length. I think the length, right, refers to the size of this structure or something like that. Let's see. I mean, yeah, it looks like that's what it does. So this, yeah, it's a bit interesting. Let's see. So we have the socket here, right? Sure, would be I guess we can have a different class, let's say, for how is it called, for the socket, to socket, for the domain, right? And let's say that class socket domain, and we have this kind of stuff, but it's gonna be af init, and it must be a function. And I think probably one way to figure out what the values are might be to just, you know, search for them in C. So for example, let me just, you know, use my for the memes, right? So test.c, and if I use this thing, I might be able to just go to definition and search for af init. Not really. But if I do af init like this, you can actually see the value, like it's 2. It's pf init, and pf init is 2. Alright, so it means that this is fine. And again, we are gonna fill in just the things that we need, basically. So the next one is sockstring. So let's see what sockstring is all about. So sockstring is 1, and I guess that refers to class socket type is gonna be a 1 for sockstring. And the last one, protocol. All right. Although for the protocol, it's a bit strange. Let's see the protocol. See protocol 5. Okay, man 5 protocol, I guess. I have no idea what 5 means, but and why does it say see protocols? Oh, protocols. So it's protocols. All right. Huh. Yeah, but what's not really interesting is like how do you get a 0? TCP. Right, like where do you get that 0? I guess we'll just trust that it's 0 or something like that. So yeah, let's ignore this. So basically, yeah, like this will be just you know, we'll call socket, and then we'll create a new socket domain called af-inet, right, something like this, and here is a sock stream, socket type. Okay, fair enough. It's I guess we can go ahead and let's create a new linux.asm file just to make it a bit cleaner, because yeah, like let's move the syscalls into a separate file by themselves, just so we can see everything here. So I think it should be a bit better. Okay, so yeah, we have like the read, the write syscall. Okay, I mean it's gonna be a bit similar, so we can, you know, always copy paste one of them. Like the idea is that these are just wrappers around. So this is gonna be the socket syscall. So yeah, basically if we go back to linux.cl, socket takes in 3 integers. So the domain, like domain is gonna be an int. The next one is type, which is int, and the protocol, which is another int. Right, and this gives us the file descriptor. So to the file descriptor object, to the int object containing the file descriptor. Yeah, makes more sense. So let's write socket, right? So here we create a new integer. Yes, that's always a good idea, right? Then we have to do something like, wait, where's the syscall? Okay, here is the syscall. Alright, so basically, right, so let's do t1 is gonna be the first argument, and we take the value from the first argument. Right, then t2 is gonna be the second argument, something like this. Pretty nice. I mean, looking at this thing, I'm really like, probably we could have used 3 address code for some of the stuff, but not everything. So yeah, it's a bit of you repeat yourself, but it's fine. And t3 is gonna be the last argument, which is also an integer, so it's the first slot. I mean, as long as you have Copilot, is really easy to copy paste code, to be honest, so it's not an issue. Okay, so t4 becomes this thing, and now we just have to set t0 to t4 and return t0, and I guess that's everything. And we only used 5 variables. All right, so 5 variables means 40. Okay, easy. Okay, doing the socket was pretty easy. So socket syscall. Alright, so yeah, let's do the next one, but after bind there's also the close that I want to do, because why there are two? Okay, sure. Okay, so we have bind, right? Bind, which is a bit more tricky because it takes in also structure, and that kind of sucks, but I mean, it is what it is. So because basically we need bind to run the server, like on any in address. This is like 000, this is the port, and no idea what this is, but I guess it's IPv4 or something. So let's see, let's just take bind. Alright, so this one takes in a file descriptor, which is the integer, right? It I mean, we can split it, but yeah, I don't know how bind will actually work. So maybe we can take a look at what sock address is, if there is a man page for it. Okay, so because we need to be careful and create, so it's gonna have SA family, the address family, and then the data socket address, right? So then it's gonna have a data, so bytes, right? And here we have sock address in, which has the port and then this other thing, which is an in address. Where's the in address? And the in address is an whatever this is, in address type, and in address type is a uint 32t, and import t is a what? Is a 16-byte number. So yeah, we usually have 64 bytes, well, I mean 64-bit numbers in cool. That's how they are implemented, using keywords. So this is just a double word and this is a word, right? So if we think about it, how this structure looks like, it has the thing, right? SA family T, which, to be honest, I lost it, but it's probably like an integer or something, like completely useless. So this is gonna be an int, right? And then we are gonna have the data. Alright, so that's how I'm thinking. So the question is, how can we create our own data structure to work like this? So I guess this is, we are gonna try to have this kind of structure. So sock address, let's implement it. So it's gonna take in I just want to see how the argument is called. Damn it. Okay, let me just open another man page for bind. I just want to see, not this one, the second one, I guess. Just wanted to see the name of the variable. So the first one is sockfd, right? This is an address, and the address is gonna be, how is it called? It's called sock address. So let's do sock address, right? And I guess for the sock address, because there are, you know, here we can use inheritance, for example, but I don't see a point. So it's kind of like the size is gonna always be the same, so and that's a good point, but you know, you kind of want to be able to like kind of port all of the syscalls, so it should also have address length. I think it should also have address length. So yeah, and now we should implement the class for sock address. So sock address, right, how I'm thinking about it is that it's gonna have SA family, like here, SA family, and SA data. So it should be like this. Damn it. So it should be like that. I think. Okay, let's see what's next. And I guess the sock address in is a bit different because it has those variables there. So let's see how we can do it. Sock address in, right? It's I don't see what's the thing with the 0 here at the end, that, but anyway, it's gonna have, again, it's gonna have the same attributes because we can inherit from it, but it's gonna have a different constructor. So the init method is gonna take in a scene family, so it's gonna take in a scene family. So let's see, scene family, right? Or is it like, okay, command to socket. Here it says like domain and stuff, so well, whatever, it doesn't matter. So it's gonna take in scene family, scene port, and scene address. Right, so it's gonna take in these values. So just want to see, so this one has here in address, which is another structure. Okay, so yeah, it was like, it's a structure inside of the structure, I guess just for alignment or something, right? For some reason, that's what I think it's for. I don't know though. Oh, yeah, maybe, I don't know. So I guess the in address right? What I kind of want to do is to basically put these values into the data. So and it feels like a bit of a struggle. I mean, this is not correct anyway, so it should be like this. And here in prelude.cl I have this byte class, which takes in an integer and gives you back only the last thing. So I can say something like, because the port, I can see that the port is only 16 bits and the port is, strangely enough, it's the first one. That's really curious because it's the first one. It's pretty weird. Like the struct sock address in, won't it be aligned? Let's see. So here let's just copy paste this stuff, right? Something like this. Okay, let me just include everything, although we don't need everything. So let's just set stuff. And let's see the size of, wait, did I just, I mean, sure, why not? Oh, it's in here, so gcc test. So the size of this thing is only 16, but 16 as in bytes. So interesting. And I guess if we take a look at the size of this, is the same thing basically, like there's no difference. Yeah, so it's the same thing. And what I'm curious about is if we can take a look at each individual field, what size they have. So here let's also run test. So it has size 2. Scene address, let's see. I'm so curious about this one. Size 4. Whoa. And scene port has size 2. So interesting. It means that regardless of yeah, so it means that regardless of they are all aligned on some level. They don't get how. Did I try this one? I think I did. Yeah, like this one's 4, this one's 2, and this one's also 2. Interesting. It also has that pad to size of struct sock address. Oh. Interesting. But this sock address Oh, it has 14. Okay, I get it. So this thing, even though it doesn't say that, it has some crap here. Okay, so import, as I've seen, is 16. So yeah, it's like only 2 bytes. So what we can actually do here is pretty interesting. I mean, the size is then kind of pointless because boom, boom. Yeah. I mean, it really is a bit difficult, to be honest. So I guess the easiest way to do stuff is, yeah, sure, let's say that we keep this as an int, but in the manual we see that as a family T, or like I guess in here we saw that that's only 2 bytes. So we don't really have stuff that has 2 bytes in size, or like shorts, you know, we don't have that. So I mean, I guess the easiest way, let me just see. So this thing takes in a reference. So we have to pass in a reference. It's not a big deal. But yeah, I feel like everything should be a string in here. We cannot really keep integer because integer is gonna have 8 bytes. So it's gonna take up all of those 8 bytes. The other option is to have but even with the bytes data type that I have in here, the byte data type still has this thing. So then yeah, like the only way to use this thing is with the data itself. So I guess it must have a string, and that's the only thing that it can have. Right, like that's the only option. And then I guess we can take that string from the, okay, so let's just keep data in here, right? So how are we gonna do that? So we should take, let's say that we have a b which is a type byte. It's a byte, right? And we kind of want to use, or I guess let's call it scene family 1 is gonna be the part of here, so it's gonna be a new byte from int. I think it's from int. Yeah, it's from int. So we have to pass in this stuff, right? But then we need syn family 2, which I think for this one we need to syn family, we need to shift, but I mean we cannot really shift, so we have to use division by 256. So this is gonna be, even though it's an integer, right, the value that it's gonna contain is gonna be only the first byte, and this will contain the second byte, I think. So that's that, right? So then we need syn port 1 is gonna be again the same thing, right? Like if you take a look at the manual, syn port is 16 byte, is a uint 16, and in address is a uint 32. So I guess we're gonna do this thing. Okay, it kind of gets it. It kind of gets the point. So we need these, all of this stuff. I mean, sure, it could have been like an extern function and do all of this in assembly, but I mean, let's just try. So what we need to do is say something like SA data is gonna be syn family. I think I have two string, yeah. Syn family 1 is gonna be toString, and then we have to use concat and concat everything basically. So these are gonna be 1, 2, 3, 4, 5, 6, 7, 8, and 8 is the size that we got there, right? 8 was the size that we actually got, but we also need 0, which is gonna be a byte with 0, and now we need to, well, actually this one is easier because we can do concat 0 to string, and we can actually repeat it 8 times. So yeah, and this is gonna be the data from the structure. Repeat is defined in the string, so what it does, it just applies concat multiple times. So that's the idea. Yeah, we don't need that. So this just sets the value. Okay, actually we need it, and here we return self. So yeah, basically this is how, let me see if, okay, this is how I think we have to do it. And it kind of sucks, but it's just the fact that we don't have different sized data structures, right? Like, I mean, we could define like bytes, sure, but the bytes are in fact byte sized, but it's not really useful. Well, anyway, we kind of have this stuff. So now when we pass in the sock address, this is always going to be 16. So sure, this can be like this. like we can have an init method. Oh, but we cannot. Oh, yeah, because it's not the constructor. Anyway, we can have size, or how is it called? Address length. So it should be, yeah, it could be SA data length. So I think this is what we need to be able to actually define this bind method. Wow. Okay, and let's take this one. Socket bind. All right. So linux.cl. So it should take in sockfd, which is an integer, address, which is sock address, right? And its first field is going to be an integer, and address length, right? And usually bind, I think, throws an error or something like that. Bind, like what does it return, right? It returns errors. So point one int object containing the return value. Sure, why not? So here we create a new int object. Here we take the value, right? Then for sock address we need to take this. I would say .s actually. Right, so we take the first slot, then we need to add, but I think we need to take the pointer to it. We don't want I guess let's think about it. So if we take the first slot, we take the pointer to s data. If we dereference it, we are now at the beginning of s data. If we add some stuff to it, I think we are at the beginning of s, but I don't remember if we actually have to dereference it to actually get a string. I think like makes sense, we should be, but it's actually slot 1 because the string comes after the int. So yeah, that's that. We take the reference to the string, or even though it's a string, it's more like the data. That's the idea. And t3 is gonna be address length. Sure. Oh, and here I forgot to actually call the right syscalls. So socket is 41. It's in binary, right? Yeah. Right, and then we have bind, which is 4090, 49, bind. Perfect. So this means that we can actually go into examples. Let's call it server.cl, class main. Let's define the main that returns an object or whatnot. Let's have a Linux type Linux. It's gonna be a new Linux. Okay. And I guess let's do it with let. So let sockfd is gonna be an int gonna be linux.socket linux.cl, and as I said, we have this socket domain .af inet, right? Then we have I think it's socket type, yeah, sockstream. Looks good to me. Okay, then okay, we didn't define yet the well, I guess scene family is also gonna use AFINet, but scene port, man, sock address. So scene port, where does it come from? I mean, it's like a number, but where? Oh, well, yeah, it's 0. All right, I guess. This is like a sock. Damn, this this is the what? The S address. So it's in address. So it's this one, in address. I guess why not have class in address. I mean, sure, it makes sense to have the but yeah, you know, I would have the host to long and host to stuff done separately, so I don't see the point. Like, I would say probably how is it called? In address any. In address any. It's gonna return a 0, and I guess we can have these classes. Let's put them like they are util classes. Host to network, right? And they don't need to be external. I mean, we can easily implement them by hand. So host to network short. So this is gonna be a short, right? So 16. Let's see how Copilot tries to do it. I'm curious. So, whoa. Wait, what? You divide by 256. Okay, makes sense. You move it to the right. To be honest, I would also modulo by 256. Like, I would divide by 256. Okay, how I would do it is probably short modulo 256, then you multiply this with 256, right? And we add this thing, we divide by 256 and modulo, just because the trash, like the number can come with some trash in it. But yeah, it is quite scuffed. I might just have to yeah, I don't even know where the line can be drawn so that, you know, to make things as easy as possible. Like the sock address structure clearly cannot be anything except a string, because we don't have the, well, I mean, yeah, as I said, the byte still is an integer. So it fills up the space. Yeah, it cannot be. So, I mean, it is what it is. And the long one, does it have to be like that? I guess so. It's like moves the last one. Yeah, I think so. Okay, anyway. Like on 0 it's not gonna have any effect anyways, so it's fine. Okay, let's go back to server.cl. So in here we need a new sock address in, but it's gonna be sock address. So let's say address is gonna be sock address, new sock address in, and we can initialize it with this stuff. So something like this, right? So that's the port, and the scene address, it's gonna be in address. So new in address, kind of like that. In address any. So I think this is how we can define the address. Oh, this one should be in it. All right, so what's next on the list is actually calling the bind thing. So I guess addr len is gonna be equal to addr.size, right? addr.size, I mean it's len, so addr.len. Yeah, bind result is gonna be this stuff, bind result. Okay, we don't have listen yet, though it's pretty interesting. But what we can do is new IO, out string socket out integer. Okay, let's do just this without anything else. So let's see if this thing, first of all, if it compiles. Like that's the first thing. So let's do cool. Yeah, I was playing around with the float. So it should be server. Yeah, let's use mallocator just in case, and let's call it server. So it doesn't like something. It doesn't like inside of the Linux file something on line 16. All right, so I put some semicolons there. Ooh, okay. So on line 50 there is like you only care about the first error usually. Like if you fix the first error, most of them are gonna be fine. And here it says that unexpected ident, no, expected ident got an int. So something is wrong before this token, and I mean it was an extra comma there. So. Yo, this is interesting. Alright, this is strange. Let me just see the checker. Okay, what? This is pretty strange, I guess. Let me just remove the test. What? I mean, I just removed those. So weird. No, like git stash. Let's see. Like, was it working before? I have those. Okay, git stash pop. Like it cannot really be because of the new stuff. Like, there's no way. Right. There's no chance that it's because of the new stuff. But maybe it is. And that would, to be honest, that would suck. So. Okay, let me just comment out everything in this file then. Just to be able to run the checker. Alright, so it actually works, right? But then it means that we have a problem in the compiler. So, like, let's try to comment out this. Like, maybe we have too many classes. Okay, what? How is it already defined? Wait, what? Oh, I guess I made an oopsie doopsie probably. Like, this is read, write, socket, bind, syscall, and you see the error, yeah. So, but I don't get why. Anyway, like, this still works, right? That still works. So the issue is that it didn't even got there. So something went wrong inside of this stuff. So let's keep some of the classes like this. See if this changes anything. Still works. Still works. So if we add, let's say, this class, does it still compile? No longer compile. So it's something to do with this. Or is it just that it's over because we have too many classes or some shit like that? No, it's because of this this literally, oh, but wait a second, Like, I haven't used inherits in this one, and here it doesn't complain that as data is not defined. So how does it happen that it actually works on that? Inherits sock address. Yeah, I don't understand how it's working though. So this is self type. So strange. Interesting. Okay, so it means that there was probably an error in the compilation of this thing or something, but I don't get why undefined method socket in class Linux. Alright, so I mean we have to define it. That's what I'm trying to... Okay, so it actually compiled. So if we build server, we get the socket. That's interesting. Yeah, like the issue probably was that we were getting some semantic error because this was the wrong type. As data was not defined in this class, we had to inherit from sock address. But yeah, strange, pretty strange. We don't even have length. I mean, yeah, many problems, I guess. But I'm not sure why it didn't show the semantic errors. It should show them. Strange. So server.cl. Alright, so now we can actually out string. You can also see the bind result. Let's see. The result is 0, so it means that it worked. I mean, sure. Probably it's gonna keep working. But that's a good thing, right? So I guess the next stuff is that we can actually listen. So let's see, man to, okay, not here, let's maybe here, man to listen. So this one takes in a sock file descriptor and the backlog. I have no idea what the backlog, I guess the backlog is how many you can have. So listen fd, okay, perfect. Like listen is so simple. Come on, let's do it. It's gonna be easy. I guess the hardest part hopefully passed. I mean, this is so ugly. I really need to find a way to make it nicer, but okay, so listen is 50. So it's gonna take that and that. Awesome. So I guess it's gonna be similar to socket for some reason. I don't really have an explanation why it's gonna be similar, but listen syscall. I guess would have been more similar to this. So this is the backlog. It's gonna be an integer containing the result or something. Yeah, this one. Okay, whatever. So for this one we need to create an integer for the result. We need to take the value of the file descriptor of the sockfd. We need to take the value of the backlog. We don't need this one. We can decrease this. Syscall listen. This is gonna be 50, I said. Perfect. We store it there. do that. I think it should probably just work unless we make the mistake again. So now listen result is gonna be something like this. Let's see what happens if we actually build and run. Still 0. I mean, yeah, still 0. Interesting. Interesting that we still get 0. And now we need the accept. We need the accept. So, oh my god, man, if we get like the right to actually work, that's gonna be insane. Okay, so here we need a while loop, right? And we need the accept syscall. So where's the accept? Where's the accept? Accept is the 43rd one. Okay, so let's go into linux.cl. Accept comes after connect. So connect is for what? Is for little, is for the client, but let's not do the client, we'll do just the server for now, because I mean, let's be honest, this is really hard by itself. So here it takes a SOC address, which we already have, thank God, and I don't know what this null is. So I guess it's the time for the manual. Accept. So it takes in a SOC address and the SOCLAN. Ooh, this sucks. Well, I guess it doesn't suck, because we can actually, like, it's super easy for us in external functions to treat these things as pointers. So yeah, it's pretty cool, but I don't know how we can put a void for an integer. Well, I mean, doesn't matter, it's gonna be an integer, it's whatever. All right, so this gives us back the connection file descriptor. Okay, makes sense. So let's go to, we don't have to do anything in this, we just have to go to Linux Awesome, go to, no, classical socket, the socket one, and we just need to put this one here. Did I paste it? I have not. What happened? Am I going crazy? I have it twice. Okay, I have it twice. Perfect. So this is gonna be accept, right? And as we just saw, accept takes in the file descriptor, the address, again the same garbage structure. I really hate it. Whoa, so it's the same as bind. I have a better idea then. How about copy pasting bind then? So we copy it, then we paste it, and this is going to be accept. So accept is going to take in the same stuff, although these are nullable. I don't think we care about that. Containing the connection file descriptor. Sure, fair enough. So this is the accept. Here we create a new integer for the file descriptor. We take the first thing, right? We take the first thing. Then what's interesting is that we pass in the structure. We pass in the structure. That's a good one. I guess like we want to pass in S data somehow, but we cannot really pass S data. We need to pass S again. Like that's the only way to do it. Even though it doesn't make sense, we need to pass in the pointer to S, I guess. Probably. Anyway, so here in this one, we want also the pointer to value. So we don't want to move it into RAX. We want to keep it as a reference. So like this. And move it. So yeah, this is never gonna be null. But hopefully if this thing is null, then this thing doesn't really care about it. That's what I hope. Right, because we cannot have null integers. Like that's it is what it is. Oh, but we cannot really have null this. Well, then it is what it is. We have to pass them in. We have to pass them in. So 43 is the syscall for accept. And then we get the result. So now if we go into server.cl and let's say that we make a block. Block is a good data, good structure here. Whatever, let's skip that. Right, let's just skip it. And let's do a while. While true. Basically this will never loop, and let's pull. Like this will never stop. Basically that's the idea. Here we need the let statement, and we are gonna have a client file descriptor, and we try to accept. And here, sure, we can pass these guys. We can pass these guys. Right, we can pass these guys. And how about in client? So yeah, we also need close. So I guess close makes sense to implement it with open and stuff, but I mean close is close. It's let's imagine that I had it a while back, right? Like close is, I don't even know, it's just like exit. Wait, close returns something? It's so weird, I never knew that. Yeah, it actually returns error status. Okay. The more you know. So it's gonna be, I mean, let's just copy the read syscall and, you know, just, okay, already a bit. Okay, so open, actually close syscall. So it, on the stack we have the file descriptor and the int object contain the return value and stuff. So we create a new integer, we take in the file descriptor, we delete all of this stuff, and we just call to close, which is the third syscall. Perfect. And I forgot to do that. Perfect. And I guess, Usually I would just say return t0. Wait a second. When I did these guys with bind, for example, yeah, I actually did like this. Okay, sure, fair enough, makes sense to me. So here we want to set, oh, like that. So I think we only needed 3 variables, so that's 24, and we only used 3 variables, so it's 24. Okay, perfect. So now we also have close. Wait, command to open. I'm curious, open, what does it do? It takes in the file path. Okay, so we don't care about it. So for now, maybe in the future we'll allow open file name flags. Pretty cool. But yeah, we close the client. So let's see what happens if we actually, the fuck? If you it just runs, right? It just runs. What if we try to netcat? Okay, nothing happened. I guess I'm not really surprised that nothing happened. I wouldn't say I'm surprised that nothing happened. I guess I know why though. Because we forgot to specify some host to network, right? And then tones, and then we use port. And I guess in address any, oh my god, let's see on Linux. I mean, we already fixed the issue, like it's GG. So it's the protocol. Am I going insane? Okay, it's the scene address. So I don't know how to call it. I mean, I would say, yeah, whatever. We fixed the issue anyway, so. Whoa. Whoa. Or at least that's what I thought. Well, I mean, I thought it's pretty obvious that we don't have constructors, but Copilot is still trying. Okay, so we have that. And now if we just, okay, ladies and gentlemen, I mean, it's not that crazy, like we just wrote some wrappers for some assembly functions, but it's still amazing. Even though we got a segmentation fault, right? Look at that. It just appeared, like it connected. The return status, it worked, like netcat worked. What the actual? But for some reason, yeah, this guy, the close guy, didn't like it. I'm curious why though. Linux.cl, I'm curious why I didn't like close, because here close comes into the file descriptor, yeah, so it might have gotten a 4 but inside of an int, right? So it must have happened like that. So close, here we take the, yeah, I don't get, oh, because it should be arg0. Alright, so oh my god, yeah, I don't know why Tmux has that, like after you move, it keeps the prefix open, like it doesn't make sense. I entered the command, just stop that. if anyone knows how to fix it, I'd be happy. Okay, so okay. Well, I guess we actually managed to do it. So I guess that's that. And the last thing that I wanted to do for the server was, as you can see in this example, it's to write something to Linux write. So let's actually try to write something. So linux.write, I guess that's enough to do it. Whoa, linux.cl. Yeah. Actually I don't like this, but I said that the string comes with, I said like the string comes with its length, but it's not really correct, because write, like, you can partially write, you know, like I should do here like count. Is it called count? Let me just check. Man to write. Yeah, it's called count. Like, I would rather have count here and fix the errors than, you know, not be true to this. So the last thing that comes in is the count. So yeah, let's say that arc3 is gonna be actually the value, so it should be like this, and basically nothing changes. Well, I mean a bit, but not that much. So we should fix the compiler error now. So inside of prelude, here on which line, 23, we do Linux write, we should do length, right? That's our outstream method. Okay, so let's go back to server.cl. So should be like that. And now if we actually just try to, we also get back a hello world message. That's just amazing. I mean, yeah, we actually implemented web server in cool. How about that? Yeah, I guess the only thing I really hate about it is the, let's go to the rant section, I guess. So the only thing I really hate about it, where is it, the prelude, to be able to hate on it. First of all, the fact that we don't really have short data types, but I mean that's not really an issue. Well, it becomes an issue in here. Like, I really hate how this looks, but yeah. I guess even if we had short or something, this is still weird. Yeah, anyway. Yeah, I mean, I guess it is what it is. I don't really have a better option to do this. Yeah, sure. Maybe, yeah, though, even if it were like an option, it would have probably sucked. So yeah, like, it's funny because byte in our language in cool actually has 8 bytes because it's a double Q word, or I mean it's a Q word, not a double Q word. What am I saying? But yeah, like the string, sure, yeah, fair enough. It's I guess it's fine. Yeah, it's not that bad, I guess. I guess it's only the fact that we don't have shift operator, and probably doing it like this with multiplying with 256 looks a bit strange. So I guess, yeah, like I guess maybe what I have to do is to add a shift operator, shift left and shift right, and that might make this look a bit nicer. But you know, like I guess in C, when you have shift operator, they convert it straight into assembly shift. So for cool it will still be multiplication, so it's not going to be efficient, still going to be multiplying. So I mean, it doesn't even matter. So yeah, it is what it is. All in all, it's decent. Like at least the interface should feel nice, right? You can add this stuff easily. Maybe the only thing that's weird is that these are integers. Maybe it would have been nicer if these were, let's say, this type, and maybe this was returning, I don't know, like this was returning the stuff itself, was returning self or something, and then yeah, basically this was using it, and I guess, I don't know, the value would be external, but yeah, that would make it a bit more difficult. But I guess it's still kind of true to the well, yeah, I mean, these, like building this structure wouldn't be difficult to use here, like this class, you know, something like that. But it would kind of suck here, because if you look at the manual for a socket, it's an integer, right? So I want to keep it as close as possible to that. In here it's a structure, but since, I don't know, yeah, it's like you cannot really pass in a string, like, at least that's a structure, and the interface to it looks fine, I guess. Yeah, so probably it's all right. Sure, now we are missing the stuff for the client, but I mean, in my opinion, this is a good result. Like, sure, maybe the other thing that we can do here is, let's say we have a buffer. Let's just do it. Buffer is gonna be string, and it can be like empty. And let's Linux read like this is, let's see if this works. Like it should, because it's, what? I put yeah. Ooh, read of class Linux applied to the wrong number of arguments. So let's see, linux.cl. So read, yeah, this is also a bit strange. I should have put, No, but I'll change that some other time. But like read. Oh, but you know what's funny is that we can actually read here. Like, how about that? And client whatever dot string sed buffer, like that. Oh, obviously. So I think it will hello, client said hello. It's funny how it just works after you do something. A B C D. I mean, yeah, it just works. Yeah, I mean, say like we also have also, yeah, it the only thing is that it's not removing the new line, but it doesn't matter. That's what the client said, so that's what the server showed. All right, so I mean, yeah, we actually managed to, whoa, we don't have the addresses in use. See, like now we got the error. But like I don't think this will work anymore now. You have to change the port basically. But yeah, after some time it will come back. But it's funny that we actually also saw it getting the error because I guess when we read data from a client, it can keep the connection open for some reason. Yeah, I don't know. But we actually managed to build a web server in cool language. Actually, it was more like implementing the server in assembly, right? Like we did a lot of bindings for syscalls, but yeah, like no, now we have the build, we have the game. Make examples. We have, like, we're able to create a game, we're able to create a web server, and so I mean, I guess what's next? An operating system. I'm just kidding. Like probably doing advent of code in cool. Like we have enough time to create a better standard library or something, but yeah, like maybe a multiplayer game, I don't know. So yeah, I guess this was everything for today. And yeah, see what's really fun now is that we don't even have to modify the source code of the compiler. It was just purely the CL code. But yeah, as I said, yeah, I guess we are done for today, and I'll see you in the next one. So see you.